And I am going to introduce our next speaker. This is Brian Van Weele with the Buck Institute. I am so honored, Brian, that you decided to join the movement. And the Buck Institute is a premier global leader in the biology of aging. He's going to share a bit about how their scientists are turning breakthroughs, and some might say miracles in health, into practical steps that you can use right now. So please, welcome, Brian.
Thank you so much, Kathleen. Delighted to be here. And Rex, always great to see you and happy to count you as a member of the President's Circle here at the Buck. So thank you for that. So I'm with the Buck Institute for Research on Aging. We're a biomedical research institute located in Northern California. And we have a pretty simple mission. Our mission is to help people live healthier longer. And in many respects, we were the earliest pioneers, focusing solely on the science and research of aging. And we help introduce the concept of geroscience, which is now adopted and accepted at NIH and throughout the field. And geroscience is this idea that the study of aging and the intersection of aging and disease is very real, and how aging plays out drives our um, susceptibility and risk of many of the diseases we tend to associate with getting older. And there's a couple key takeaways that I'd like to share in this brief little talk here. One of them is aging is the greatest risk factor for every major chronic disease. And when you see it on a chart like this, it's a little sobering, but what we know about aging is that it is driving all of the chronic diseases, and you can see them listed here as we get older. And our risk of these diseases and our mortality associated with these diseases rises exponentially as we get older. And so, what we're beginning to understand at the Buck, and was really the early hypothesis of the Institute, is that through this idea of geroscience, if we want to attack and combat these diseases, the best approach is to understanding the biology of aging and intervening where we can. And part of that is this concept that aging is not fixed. It really is plastic and malleable. And that was something that was not well understood even just 25 years ago. Many researchers going back into the 70s and 80s and early 90s didn't believe you could do anything about aging. But we now know through our research and our studies and our clinical trials that you actually can affect the rate and pace of aging. And it also introduced this idea of health span versus lifespan. And you look at the top graph, the normal trajectory of a lifespan includes a fairly high percentage, 15 to 20% of our lifespan is dealing with these chronic diseases we associate with aging. And so the goal here is, what can we do? What interventions through pharmaceuticals, as Rex mentioned, or behavioral or lifestyle factors, what can we do to actually push out that curve a bit, to create more space under the curve, and that space being health span, and health span being defined as the healthy years of life. So that what we're doing is we're creating more health, vitality, uh, later into life, and that period of morbidity is compressed. And so, while we still may need to deal with some of the end of life issues that we deal with today, rather than it taking 15 or 20 years, maybe it's 1 or 2 years. And we've had all this great health and vitality to follow and pursue our passions and our purpose. Another takeaway is that aging is really a systems problem. There's not just one silver bullet that's going to do it. We have evolved over millions of years to have a very, very complex biological system that has multiple layers and connections and tremendous redundancy. And it's really like a symphony in some ways of how everything comes together. And so, really, in order to understand biology, we need to understand the many levels, from a molecular level to pathways to mechanisms, to really find ways to intervene and improve our health wherever possible. And that was how the Buck came to be. We were the first uh, independent institute to focus solely on aging, and we opened our doors in 1999. And today we have over 200 scientists who come from over 35 different countries, and all they do is study aging. They have different areas of expertise that they research and different areas of emphasis that they pursue, but they're all united by this belief that that aging is driving chronic disease, and that the best way to attack it and understand it is to decode the biology of aging. And we're located up here about 30 minutes north of San Francisco. We have a wonderful IMPay designed campus. And that is really what we're looking to do. And I thought what I'd do is just in the 1 or 2 minutes I have left to share a little bit of how some of this is playing out, particularly with one of the diseases that we're studying at great depth, Alzheimer's. And what we know about Alzheimer's is currently there's about 7 million people in the United States alone that have been diagnosed with Alzheimer's. And some people project that to almost doubling to 13 to 14 million by 2050. Today, 1 in 9 people have Alzheimer's disease. And amazingly, more people die from Alzheimer's than they do from breast cancer and prostate cancer combined. So it really is something that is a top priority and for the Buck and for health in general. And so one of the couple of things I'd like to share is that what we're trying to do is develop new interventions, new ways of restoring balance and rescuing the body and biology when it goes off balance and is out of sync or dysregulated. And so Dr. Ellaby is one example of one of the things that she's just tackling is how can we prevent the onset of Alzheimer's? What are some strategies there? And so one of the unique strategies she approached is taking the Zika virus, re-engineering it, removing the virus, and and designing it so that we can put good cargo on the virus. And the reason she chose the Zika virus is it has a very unique feature of being able to cross the blood-brain barrier with ease. And that is one of the biggest impediments to getting interventions into the human brain. What she can do with that is she can now, with this Zika virus, and we're in clinical trials today, is she can load positive cargoes like different proteins and different drugs and target parts of the brain, introduce CRISPR, introduce other technologies. One of the things that I'm fascinated with is she's loading and testing this virus, bringing it across. She calls it the zip delivery system to with ApoE2 to bring into people who have ApoE4 alleles, which put you at a higher risk for Alzheimer's disease. And beginning to test in animal models, can we rescue and prevent the onset of some of the disease? And so that's one example of prevention. On the other side, we have Dr. Tracy, who's looking at rescuing brains that have are already experiencing some declines in cognition. And so her discovery is that there's a particular protein called the Kipper protein that as we age, we see a decline in this protein in our synapses, and that we see a loss of synaptic function that's associated with cognitive decline. What she's discovered is that by putting that protein back into these cells, we can rescue or restore synaptic function. And this is particularly happening in the hippocampus, and this is the area of learning and memory. And so she's actually developing working with Lisa to use the zip delivery system, but also developing an inhaler technology that might be able to bring that protein into the brain and hopefully begin rescuing brains that have already been impacted by this terrible disease. And then finally, and I think this is one of the big trends, we've made a major push into AI technology and phenomic studies. Our lead scientist here, really we have two, Dr. Lee Hood and Dr. Nathan Price. They wrote a terrific book called The Age of Scientific Wellness, which I highly recommend. It talks about really the future of medicine and how AI is changing where we're heading. But the cool part about this is that we're actually beginning to apply these technologies using 25 years of our research to train these engines and these large language models to begin in essence, building kind of a digital twin or an avatar, if you will, that we can start using to deliver personalized insights based on your biology relative to your risk and whether also interventions would work or not based on your unique biology. This is completely the cutting edge and where things are going. As technology, as Rex kind of and Kathleen mentioned, is changing the game. And we're very, very excited about it. And I do think this is about just a year or two away. So that's a brief introduction to the Buck. And thank you so much for inviting me to be part of this.